Good evening, students. How are you all? Hello, Shillong Center, St. Paul High School, and Kohima. Okay, so in the last class, we have started the Venn diagram, and we have done the basics of the chapter set. We have done the what are set and what are the representation of the set and subset and types of set. We have done power set. We have done. Okay, so today we are going to start with the next topic in the set, the third topic, which is the Venn diagram. So this is the next topic in this one, which is the Venn diagram. So basically, what do we mean by Venn diagram? This is just a graphical, you can say a pictorial way to represent a set or set represented in the form of diagram. A set's represented in the form of diagram, that is called the Venn diagram basically. And this Venn diagram can be of any shape, but make sure it has to be in the closed loop. Like it can be a triangle, it can be a rectangle, it can be a star, anything. It can be anything, but it has to be a closed loop. So, but in general, we denote the Venn diagram with the help of a circle. Generally, in general, either you can use any one, but in general, we will use the circle to denote the diagram. Now, what does that circle represent? It represents that if something, let's say this circle is, name of the circle is A, and it represents that A represents all the students in the class who are studying mathematics. So it means those who are lying inside A belongs to A. It means those who are lying inside the circle will study mathematics, and those who are not in the circle A, those who are outside of the circle A, that means they do not study mathematics. Simple as that. Similarly, let's say if I make the circle B, and if I say the circle B represents the set of all persons who read newspaper daily. So it means the person who are inside this circle are those who read the newspaper daily, and similarly the persons who are outside the circle B are those persons which do not read the newspaper daily. So those who are in the circle belongs to that circle, those who are outside the circle does not belong to that circle. So this is called the Venn diagram. Now, so how we can draw different diagrams in terms of Venn diagram? Let's say if we have two sets A and B, and if I say that A is a subset of B, if A is a subset of B, it means all the values of A will be inside B. So we can draw like this: A is a subset of B. So I can draw circle A, then outside this one we can draw circle B. So meaning is that all the values of A belongs to the value of B, but all the values of B may or may not belong to B. So A is only the subset of B, but B is not the subset of A. From this diagram we can say. Similarly, second case can be, let's say there are two sets A and B, and they have something in common between them, not all of them. Let's say if we take the example, let's say in a class there are 100 students. Okay, 70 students study maths and 60 students study science. So total 100 students are there, and mathematics are 70 students who study mathematics, and there are 50 students who study science. Now you can see that total students are 100 and mathematics are 70 and science are 50. If we add all of them, 70 plus 50, it will exceed the total number of students. So how is this possible? This is only possible then when there are some persons who are studying both the subjects. So how we can draw that diagram? That diagram is represented by the intersection of the circle. So you can draw it like this. So generally the universal set which we have studied about, this universal set, this is denoted by a rectangle which represents all the students in the class, let's say 100 students, and this circle 1 and this circle 2, both the circles should be intersecting circle. It means some of the part is common in them, or you can see that here are 70 students, here are 50 students. So you can see there is something common, this part which is common. It means these are the students who study both the maths and science. Then only we can say that the sum of all the students who are studying maths and science exceeding the total. Now third case can be, it can be like this, when there are some students in the class and some are studying maths and some are studying science, but there is no such student who are studying both the maths and science. It means there is nothing in common between the two subjects. So we can draw like this. This is one circle, this is another circle. These are called disjoint set, or you can say the intersection for both of them is a null set. I hope you are getting till now. Everybody getting it? Like, what do you mean by Venn diagram? Venn diagram basically means representation of the set in the form of the circles, generally in the circle in the form of diagram. Shillong Center, are you getting it? Kohima and St. Paul High School. Okay. So now we have to learn in this one the different types of operations on set and how we can prove the different relations. So the first topic in this Venn diagram is the operation on set. So basically the operation will be like addition, subtraction, that will be the type of operation. So in the first part it is union of sets. Now union of sets means total of set. So suppose if we have two sets A and B and they are represented like this. This is rectangle represent the universal set, and this is A, this is B. So universal set, and if union of set means it is represented by A union B. The symbol U is used for the union, and the union means basically total. So what is the total number of students or total number of articles in set A and B? Or we can also say this is also represented as we can also write this one as A or B. So A or B, it means either, what do you mean by either A or B? It means belongs to A or belongs to B or to both of them. So the meaning is that either it will belong to A, it will be belonging to B, or it will be belonging to both of them. That is the meaning of A or B. So that in the form of diagram, if you want to represent, it means it belongs to either to A, either to B, or to both of them. It means the complete complete union of those two sets is known as the union of set. Union of set basically means we are adding all the values of both the sets. That is called union. So the symbol which we will use is U, and for union we will write A or B. The or meaning, the meaning of or over here is that the union. So the notation we will use, it will be like if X belongs to A union B. If X is an element which belongs to A union B, it implies X belongs to A or X belongs to B. If X is an element belonging to the union of A and B, then it implies that X belongs to A or X belongs to B. Either it is an element of A, it is an element of B, or it is an element of both of them. Similarly, if X does not belong to A union B. Now, if X does not belong to A union B, it means X does not belong to A and X does not belong to B. So, here the two words which I am using over here, which is or and and. So, the or and and, the meaning of or and, the meaning of these two words is that or means total and means intersection, or intersection, or you can also say common, and total, or you can say union. So if we say that A belongs to A union B, it means A belongs to A or A belongs to B. This notation you have to remember. Second thing, if X does not belong to A union B, if X is the member which does not belong to A union B, then X does not belong to A and X does not belong to B. We can understand with this one how we can understand this thing, or and and. The meaning of or and is that or is the total, and this and, the meaning of this and is the union intersection. So you can understand in this way: X does not belong to A union B. The meaning is X does not belong to A and X does not belong to B. Now, how we can learn it from the Venn diagram? Suppose this is the case. So, X does not belong to A union B. It means from the left hand side we can say that X is a member of this part. It is not a member of A union B. It is a member of the outside region of the A union B. Similarly, this represents this one. Okay. Now, the right hand side diagram, how we can say that both are equal? So, X does not belong to A. So, now here is X does not belong to A, this is A and this is B. If X does not belong to A, it means the region is this one, all the region in which we can say X does not belong to A. And similarly, X does not belong to B also, and X does not belonging to B, it means we can say this region. And if we take the common out of these things, so if we take the common out of these things, we will be left only with the same region. So this is the meaning that X does not belong to A and X does not belong to B. So always remember these two things. If X does not belong to A union B, it means that X does not belong to A as well as X does not belong to B. And if X belongs to A union B, it means X belongs to A or X belongs to B. This is the meaning, you can remember it like this. So if I say, let's take one example. If we have the set A as 1, 2, 3, set B as 1, 3, 5, 7. These are the two sets, set A and set B. And if they ask, find A union B. So A union B means the total of the elements of both the set. Now here we have to make sure that the repetition should not be there. So repetition means 1 will be there, 2 will be there, 3, 5 and 7. This is the meaning of A union B. Similarly, the second part is, this was the union of set, it means total. Now it is intersection of set. So intersection of set means collection of elements. If there are two sets A and B, then intersection means collection of elements which belongs to both A and B. So basically the intersection means which is common to both the set. So if we draw the diagram for this one, let's say the Venn diagram. if this is set A and this is set B, so intersection means the region which is common to both the set. So the region which is common to both the set is this region which is common to A and B, this shaded region. This is known as the intersection of the set, intersection of A and B. And how we can represent that one? The representation of intersection of A and B like this: A, inverted U symbol is used, A intersection B. This is the symbol to represent A intersection B, or we can also write A and B. So AND operator also represent the intersection, and this inverted symbol also represent the intersection. Both of them represent the same thing, and intersection also means the common, which is common to both of them. So if we say generally, if X belongs to A intersection B, then it means that X belongs to A and X belongs to B. This is the meaning of intersection of set. If X belongs to A intersection B, it implies that X belongs to A and X belongs to B. It should be belonging to both of them. Then only we will say X belongs to A intersection B. So inverted U symbol means if there is inverted U, we have to use AND over here, AND operator. If it is U simple union, we have to use the OR operator. And let's take one example. Let's say if we have A is a set having elements, let's say 1, 2, 3, 4, 5, and B is a set having element, let's say 5, 6, 7. Then if we have to find what is A intersection B, so A intersection B, it means from both the set you will figure out only those elements which is common to both of them, and the common element in both of them you can see only 5 is common. So we can write A intersection B is 5. This is the meaning of the intersection of set. Are you getting it till now? Kohima, Shillong, and St. Paul High School, today you have joined, I guess. Okay, that's good. Now, suppose we take one point like this. If one example we take, let's say, if A is a set of all X such that X is equal to 2n and n belongs to integer, and B is a set of all X such that X belongs to 3n and n belongs to integer. This is given, the set builder form is given. A is a set of all X such that X is equal to 2n and where n is an integer, and similarly B is a set of all X such that X is equal to 3n and where also n belongs to integer. Now you have to figure out what is A intersection B. Now A intersection B means which is common to both of them. So you can write A intersection B as set of all X, X is equal to 2n, n belongs to Z, intersection the set B, X is equal to 3n and n belongs to integer. Now if we write the elements of set A in the roster form, because this is set builder form, if we convert it into roster form, we can say that this is X is equal to 1 and belongs to integer. Integer means it can be anything, so it can be anything, or you can say all the, since it is 2n, so you can say it is all the even multiples, or you can say even integers we can say. So you can put any value. If you put Z as 1, you will get 2. If you put Z as 2, you will get 4. If you put Z as 0, you will get 0. If you put Z as minus 1, you will get minus 2. So you can say the values are like minus 4, minus 2, 0, 2, 4, 6, like that. And in this one, these are the multiples of 3 you can say. So minus 3, then 0, then 3, then 6, and so on. Now out of these two, we have to see which are the things which is common to both of them. So to common to both of them, you can see there will be one more element over here, -6, and here also there is one more element, -6. So the multiple of 2 and multiple of 3, which is common to both of them. So in the multiple of 2 and multiple of 3, the common to both of them is the LCM, which is the LCM of 2 and 3. LCM of 2 and 3 is 6. So you can say 6 will be present in both the subsets, then 12 will be present, then 18 will be present. Since all these numbers are divisible by both 2 and 3, we have to figure out those elements which are multiple of both 2 and 3. It means it has to be the LCM, multiple of LCM of 2 and 3, and LCM of 2 and 3 is 6. So we can write the common elements out of these is -6, then 0, then 6, then 12, then 18, and so on. So we can also write this thing as set of all x such that x is equal to 6n, where n belongs to integer. So this is mean by intersection of two sets. So intersection means we are taking common from both of them, and common elements from set A and set B is all the multiples of 6. Is it clear till now, Shillong? Kohima, is it clear? Okay, perfect. Okay, now third point, we have done union of set, we have done intersection of set. Third one is the disjoint set. Disjoint set means if there are two sets, if there is nothing common between both of them, like if we draw the diagram, as in the Venn diagram we have discussed the third case, like there are two sets, nothing in common. So set A is A and this is set B. So you can see there is no common thing in both of them. It means if we take the intersection of both of them, there will be no element. So you can say A intersection B will be phi, because if there is nothing in common, so the element, there will be no element in the set of A intersection B, because there is nothing in common. So, or we can say if A intersection B is phi, both the sets are to be disjoint set, or you can say if the set are disjoint, then A intersection B will be phi. Like if we take one example, we can say if A is 1, 2, 3, B is 4, 5, 6. If I ask you to find what is A intersection B, so you can see in both the set there is nothing in common. So you will say nothing is common, so the element will be phi over there. Getting it? It was an easy one. And the fourth one is difference of set. Difference of set means we have to subtract one set from the other set. So with respect to the diagram, first of all let us see how it will look in the diagram, and then we will see in algebraic way how we can solve it. Suppose there are two sets A and B, they are intersecting set like this, and so if I say like A minus B, so what do we mean by A minus B? A minus B means from the set A we have to remove all the elements which belongs to set B. So in the diagram you can see this green one is the set A, only this common region is the element which is from set B in set A. So we have to remove this thing. So from the A we have to eliminate all the elements which are the part of B. So we will be left only with this region, this pink region. So from A, if you have removed all the elements which belongs to part B, that will be known as the difference of A and B, or you can say A minus B. So in general we can say A minus, if X is the element belongs to A minus B, it implies that X belongs to A, that X belongs to A minus B, this pink region, it means X belongs to A and X does not belong to B, as well as X does not belong, X should not be a part of B, X should be a part of A, but X should not be a part of B. That is the meaning of X belongs to A minus B. So we have to subtract all the elements from A which are the part of B. Similarly, if I say B minus A, then B minus A means from the set B, we have to eliminate all the elements which are the part of A also. Like in the diagram, if this is A, this is B. So from the set B, we will eliminate all the parts which are part of A. So we will be left only with this region. So this is the meaning of A, B minus A. So you can say if X belongs to B minus A, it implies that X belongs to B and X does not belong to A. X B से belong करना चाहिए but A से belong नहीं करना चाहिए. That is the meaning of B minus A. So if I, it is very easy one, you can understand with the help of example also. Let's say if we have the example A is a set 2, 3, 4, 5, 6, 7 and B is a set 3, 5, 7, 9, 11. Right? These are the two values, two sets A and B. If we have to find what is A minus B. So A minus B means, okay, Shillong, you are asking what about A and B in disjoint set? No, in disjoint set, you can see here is the disjoint set, Shillong. There is nothing in common in A and B. So if you subtract B from A, the result will be only A because there is no element in A which belongs to B. So answer will be A. So for the disjoint set, if you subtract A minus B, that will be still A. Or if you do B minus A, that will still be B because there is no element which is common to both of them. Getting it, Shillong? Or let's take one example over here also, you will understand. Like you can see this is set A, the elements are 2, 3, 4, 5, 6, 7. Set B, the elements are 3, 5, 7, 9, 11. If we have to do A minus B, so from the set A, you have to eliminate those elements which are a part of B also. So you can see which elements are the part of B. So this 3 and 5, this element 3, this 3, 5 and we can say this 7. This 3, 5 and 7 are the part of B also, so we have to eliminate these. So you will be left only with 2, 4 and 6. So 2, 4 and 6 means A minus B. If I have to do B minus A, then B minus A means from the set B, I have to eliminate those elements which are the part of A. So 3 is present, 5 is present, 7 is present. So we have to eliminate this 3, 5 and 7. So we are left only with 9 and 11. So this is the meaning of B minus A and A minus B. Let's say if both of them are disjoint set, like if A is 1, 2 and B is 3, 4 and then I have to do A minus B. So A minus B means from the set A, eliminate those values which belongs to set B. And you can see there is nothing in common in both of them. So this same will be remaining and same will be remaining means this is equal to A also. So in disjoint case, A minus B will be equal to A or B minus A will be equal to B. This is the meaning of the difference of the set. I hope you got it till now. Kohima, Shillong. Kohima, you got it? Okay. Now write the next thing, that is called symmetric difference of two sets. Now what do you mean by symmetric difference of two sets? Basically, the symmetric difference is given by A minus B union B minus A, and that is given by A, this triangle B, A delta B, or you can say the triangle B. The meaning of symmetric difference is that difference of A and B and difference of B and A, the union of both of them. So from the if we draw the diagram, Venn diagram, so we can see that if this is A and this is B, so A minus B is this region, and B minus A, from B we have to subtract A, this is this region, and union means total of both of them, that is known as the symmetric difference of two sets. Once we have to subtract A from B and then B from A, and then we have to add the result, that is the meaning of the symmetric difference of two sets. Or you can directly see over here, if we want to represent this in another way, we can also say that this shaded region can also be said as from the total we are subtracting the common region. From the total we are subtracting the common region. We can also write it like this: A union B minus A intersection B. From the total, since we are subtracting the common region, intersection region, that will be also give us the other two region, which is same as the symmetric difference also. So you can also quote it like this: A union B minus A, because this region, this common region, the green one, this is known as A intersection B, and this A union B means total. So from the total we are eliminating the common region, so that will be also be the symmetric difference, because the leftover is this one. Like if you have to find, let's take one example, a very good example it is. If A says set of all x belonging to R such that x belongs to 0 to 3, and B is a set of all x belongings to R and x belongs to 1 to 3, then we have to figure out what is the symmetric difference of A and B. So we have to figure out A delta B for this region. Now the A delta B for this region is that first we have to figure out A minus B, and then we have to figure out B minus A, and then we have to add both of them. So to solve this one, it will be easy if we can solve it by the plotting on the number line. Now if this is the number line, the set A means 0 to 3. This is 0, this is 3, and since it is going from 0 to 3, and you can see nothing is included, so we have learned that we have to draw the open circle from 0 to 3. This is A, and the B is 1 to 3, so let's say it as 1 to 5, and the set B is 1 to 5, and both of them are included. So we can take 1 over here and 5 over here. Since both of them are included, so it will be a dark circle. So this is B. Now what do we mean by A minus B? A minus B means from all the values of A, we have to subtract the values of B. So what if in the diagram you can see what we are getting common over here? We are getting common, this region is common to both of them. So this is the region in A which is also a part of B. So we have to eliminate this region from A. So we will be left only with this part. So we can say this is the x belongs to R such that x belongs to only 0 to 1. and 1 is not included, because in A 1 is there, but since 1 was included in B and we have excluded B from the A, that's why 1 will be excluded, so we will not have a equality sign in 1. So that is the meaning of A minus B. Now if we have to do B minus A, then see, from the B is going from 1 to 5, and from this B we have to eliminate the part of A. It means this region we have to eliminate. So this region if we eliminate, so leftover in B will be only this much. Now we have to see whether we will include this 3 in our calculation or not. You can see when we are removing A, the 3 was not included in A. Let's say if they are up to 1 decimal place, so like 2.1, 2.2, 2.3, then up to 2.9 that is excluded, 3 is still there in B. So it will be x belongs to R, x is greater than or equal to 3 and less than or equal to 5. So this is the B minus A. Then symmetric differences will be union of both of them. So union of both of them we can write x belongs to R such that x belongs to 0 to 1, or x belongs to greater than 3 or less than equal to 5. There should be or operator in between since we are taking the union. Getting it? Any doubt in this example? Kohima, Shillong, any doubt? Okay, again, see, the question was, there are two sets A and B that is given, then and the region for A is 0 to 3, the elements of A is 0 to 3 and 0 and 3 not included, and here it is 1 to 5. It was 3 over there, I forgot to mention. Okay, now we have to figure out the symmetric difference of A and B. Symmetric difference of A and B means first you have to take A minus B and then you have to do B minus A and then you have to add both of them. So A minus B, if we draw the number on the number line, we can see that A is from 0 to 3, 0 and 3 not included, and B is from 1 to 5, both are included. So since A minus B means from the set A we have to eliminate only those values which are the part of B. So you can see in set A the part of B is from 1 to 3. This will be totally removed, and 1 is also getting removed since 1 was the part of B. So 1 is removed. So A which is left, this is only left up to this region. In this region this is left which is up to 0 to 1. And since 1 excluded, so 1 is not included. So this is A minus B. Then we have to do B minus A. So B minus A means from the set B we have to eliminate those values which are the part of A also, or which is common to both of them basically. So this region, up to this region, this will be eliminated from B. So if you eliminate from B, you can see that up to 0, up to 3 it is getting eliminated. But since in A 3 was not there, so let's say A was up to 2.9, 3 was not included in A, so 3 will remain in B, rest of all the values will be removed. So the B will be left only from 3 to 5, 3 included. So this is the A minus B, and taking union for both of them, or this OR operator, that is the answer for A delta B, which is the symmetric difference of A and B. Getting it, Shillong, now? Okay. Now next one is complement of set. The complement of set means, suppose there is a universal set, and I have told you what is a universal set. The set which comprises all the given set in the given context. Like if you are talking about the set of natural number, then n would be the universal set. If you are talking about the students of a particular class, then universal set would be all the students of that school. So that can be, so collection of all sets in the given context, that is a universal set. So if there is a U is a universal set, and A is a subset of U. Subset of U means A is the part of U, you can say. So universal, and then complement of A is denoted by A dash or A complement or U minus A. There are three ways to represent the complement of set: A dash, A, and over the A there is a small c which represents complement, or U minus A. It means except A, all the values in the given context, that is the complement of A. So from the diagram it will be very clear to you. Suppose this rectangle represents the universal set and this is the A. So the values which does not belong, the set of all values which does not belong to A, that is the complement of A. So here the complement of A will be this region. So basically the values which does not belong to A, that is called the complement of A, or which are in not A. So basically we can say, if X belongs to A dash, if X is an element of A dash, it means if X is an element of complement of A, it implies that X does not belong to A. Or X does not belong, if X does not belong to A, it means X is a element of A dash. So you can understand like this. Let's say if a universal set is 1, 2, 3, 4, 5, up to 10 is there, right? And A is 2, 4, 6, 8, 10. So a universal set is the collection of the natural number from 1 to 10, and there is a set A, it is the collection of even natural number. Then A dash would be given by the set of all elements except A in the universal set. So from this universal set we have to subtract those elements which was a part of A. So A dash basically means U minus A. So U minus A means from the set U, subtract those elements which were part of A. So 2, 4, 6, 8, 10 we will remove. So 1, 3, 5, 7, 9 we will be left with. That is known as the complement of set. Are you getting it till now? So we have learned 2-3 things on that Venn diagram set. On operation on set, we have learned the union of set, intersection of set, disjoint set, symmetric difference of set, and subtraction of set, difference of set, and complement of set. So based on that one, let us do some of the questions. So you should do that question and just let me know when you are finished, then we will discuss that. Based on whatever we have discussed so far. Try this. I'm saying we have done Shillong Center. We have done the operation on set, union of set, intersection of set, difference of set, and symmetric difference of set, complement of set. So based on this one, there are 4 sets, A, B, C, and D, and you have to figure out these. The inverted U represent the intersection, and the simple U represent the union. So find the set for the answer for this one, and when you are done, just let me know. Have you done? Shillong, Kohima? Okay, Shillong Center, have you done? Okay, so let's discuss. So the first one, this is set A, B, C, D are given, and we have to figure out the B union C union D. It means you have to add all of them. So either you can add B and C. Okay, complement. Shillong Center, complement means everything except that set. If I say complement of A, so you can see here we have this was the complement. So complement means the values, the set of all values which does not belong to A. Like there must be some universal set. Let's say there is a set, a universal set of boys and girls in a school. Then complement of boys means set of all girls, and complement of girls means set of all boys. Or complement of a set means the set of all values which does not belong to that set. Like in the diagram you can see this diagram. This is the universal set, and inside that there was set A. So complement of A means all the values which does not belong to that A. All the values outside A, that is known as the complement of A. So basically from the total, whatever is the universal set, just subtract that particular set, the answer will be the complement of that one, or which does not belong to that one. And it is denoted by either A dash or this A power C or U minus A. That is known as the complement. Getting it? So like the example you can see, if this is the universal set and A is the set, if I ask you what is the complement of this set, so just subtract this set A from the universal set, the remainder will be the complement. Okay, so now the question is B union C union D. So we have to add all the values of B, C, D. So now this is you can commutative associative. Like first you can do B union C and then you can do C union D, or you can do B and D first and then C afterwards, doesn't matter. So B union C union D. So 4, 5, 6, 7, 8 and then 9, 10, 11 and 12, 13, 14. That will be the value. Now A intersection B union C. So this is in bracket. So first of all we will do B union C and then we will figure out what is common with A. So this is A 1, 2, 3, 4, 5 and intersection of B union C. B union C means 4, 5, 6, 7, 8, 9, 10, 11. Now the common elements between them is only 4 and 5. Now similarly A intersection B. So A intersection B, between A and B you can see the common elements are only 4 and 5. The intersection sign. Between B and C the common element are only 7 and 8. So you can see between this A intersection B and B intersection, what is common between both of them? Nothing. So it will be 5. And the fourth one is A union D intersection B union C. So this is A union D total and B union C. Now what is common in both of them? So common in both of them, in A union D we have 1, 2, 3, 4, 5, 10, 11, 12, 13, 14. So we can see the common element between these is 4, 5 and 6 is not present, 7 is not present. Then we have 10 and 11. So 4, 5, 10 and 11, these are the common elements which are present in them. Getting it? How many of you have all the 4 parts correct? कितने सही हुए? Oh, that's great. Okay, D part. Shillong, see, A union D. If I write the values of A union D, you can see 1, 2, 3, 4, 5, 10, 11, 12, 13, and 14. These are A union D. And now we have to see B union C. B union C are 4, 5, 6, 7, 8, 9, 10, 11. So from these two sets, we have to figure out which are the common. So which are the common? The common elements are only 4, 5, 10 and 11. These are the common elements. This is the question. Getting it? Okay, now the second question. This is the universal set. 1 to 9 values are given. A, B, C are given. A dash. A dash means complement of A. It means U minus A. And from the universal set, just subtract the set A, which is 1, 2, 3, 4. If you subtract, you will be left with 5, 6, 7, 8, 9. So this is A complement. Now A union B complement. So first of all, we will figure out A union B, and then we will subtract from this one. So from the universal set, just subtract A union B. That is the meaning of A union B complement. So A union B means if we add all the values of A and B, we will get 1, 2, 3, 4. So U minus 1, 2, 3, 4 and 6, 8. So just subtract these values from U. We will get left with 1, 2, 3, 4 and 5, 7 and 9 we will be left with. Similarly, C part, A dash complement of complement. Now it means we have to subtract U minus A complement, and when we subtract U minus A from the universal set, if we subtract U complement of A, we will be left again with A. You can understand with the help of diagram also. Like this is A. So complement of this complement. So complement means first of all whatever is the set we have to subtract it from U. So subtract the complement of A from U. So this is the complement of A, the outside region. If we subtract this region from the total rectangle, we will be left with this one. So that is again the A. So complement of complement is again the same set itself. And the part D, B minus C dash. So B minus C complement, so U minus of B minus C. So first we will figure out what is B minus C. So B minus C, you know how we can figure out? From the set B, subtract those elements which are the part of set C also. So from set B 2, 4, 6, 8, we can subtract 4 and 6 because those are the part of B also. So 2 and 8 we will be left with. So from the universal set we have to subtract 2 and 8. So we will be left with 1, 3, 4, 5, 6, 7 and 9. This is the meaning of this question. All of you got it? Kohima, Shillong? Okay, that's great. So now we'll take a break, and that after the break there are some laws of algebra which we will learn, the distributive law, commutative law, and then we will solve some different types of word problem on that one. Okay, so we'll meet after a break. Okay, so let's proceed. Till now, we have done the different operations on the sets. Now, there are some laws of algebra of sets, and the way how we can prove those laws, that we have to learn. So, for that one, till now, let me make a summary for you what we have learned so far in the union of set and in the intersection of set, in the difference of set. So, what we have learned. So, just make a note of this one. This will be helpful while proving these things. So, first thing, if X belongs to A union B, this is same as X belongs to A or X belongs to B. Make sure of the use of the word or and, the two operator, or and AND operator. Similarly, if X does not belong to A union B, this means X does not belong to A and X does not belong to B. You can memorize it like this. If it is not belong to, if it is negative, the union will be replaced by the intersection. And means intersection, or means union. So if it is negative, negative means does not belong to, then it will be replaced by and. Similarly, second thing, if X belongs to A intersection B, it means X belongs to A and X belongs to B. And if X does not belong to A intersection B, now here it is does not belong. So it means the intersection will be changed to union. So it will be X does not belong to A or X does not belong to B. And third, in the difference of set we have studied, if X belongs to A minus B, it's same as X belongs to A and X does not belong to B. X A से belong कर रहा है but B से belong नहीं कर रहा. Similarly, if X belongs to B minus A, then it means X belongs to B and X does not belong to A. Right? Similarly, for the complement we have studied, if X belongs to A dash, if X belongs to complement of A, it means X does not belong to A. Or we can say if X belongs to A, this is same as X does not belong to A dash. Both are the same thing. Or you can write it in one point also, because both are the same thing. These are the things we have studied so far. So, with the help of these things, we will prove some of the laws of algebra. So, have you noted down all of you? Shall we proceed? Kohima Shillong? Okay. Note down the heading, laws of algebra of sets. The first one is idempotent law. It means for any set A union A will always be equal to A, and A intersection A will always be equal to A also. And how we can prove this one as, so it means let's say if A union A means set of all X such that A union A, X belongs to A or X belongs to A? It means set of all X such that X belongs to A, and X belongs to A means capital A. This is the way in which we can prove this thing. A union A means the set of all X which belongs to A or X belongs to A. In the union we have just studied. So it means both are the same thing. So we can write this one as only set of all X such that X belongs to A, and X belongs to A means basically this is A. Second one you can also prove in the same way. Now the identity law, it says for any set A union phi, the final set and the A, the union of this thing will be A, and A intersection U, the universal set and the set A, the common between universal set and set A will always be set A. Identity law, same thing we are getting. So for this one we can say A union phi means the set of all X such that X belongs to A or X belongs to phi. So the total of both of them, X belongs to A or X belongs to phi, that means X belongs to A. It means set of all X such that X belongs to A and which is equal to A. We can write it like this. And in case of this one, A intersection U, since it is an intersection, we will use the term AND. So we will say set of all X such that X belongs to A and X belongs to U. So X belongs to A and X belongs to U. So what is the common between both of them? So we always know that the A is common only. So X belongs to A intersection A and which is equal to A again. So this is just a basic proof of this one. These are the two laws like idempotent law and identity law. You don't have to remember these things, the way the derivation can be asked. Okay, I am saying that these are the identity law and the idempotent law. Idempotent law means like for any set A, if you are taking union of same set, you will get the same set itself. If union of two same set will be the same set itself, and intersection of two same sets will be the same set itself. That is the meaning of idempotent law. And how you can prove that one, the way of proving these things, first we will see that what do you mean by A union A. Meaning of A union A is that set of all X, if X is the element in this one, so set of all X such that X belongs to A or X belongs to A, because in the previous one we have written the law over here. This one, the first one you can see X belongs to A union B, it means X belongs to A or X belongs to B. So here both the set are same, so X belongs to A or X belongs to B, and then we can write it as, since both are the same thing, X belongs to A, total of both of them will be the same set, X belongs to A, and that we can write this one as A. And in case of identity, identity means the union of the null set and the set itself will be the same set, and the intersection of the universal set and the set will be the same set itself. Like A union phi will be A and A intersection U will also be A. And how we can prove this one? A union phi, we will say the set, since it is a union, so we will write set in set builder form. How we can write? Set of all X such that X belongs to A or X belongs to phi. We will use the operator or over here since there was union. Now you know that between A and phi, what is the total of them, which is A again. So we can write it like this: X belongs to A and which is equal to A again. Similarly, here we have to use the term AND operator, and this one. This is the very basic way of proving. The next one which we are going to do, in which you will learn how we can prove those two things. Okay, so commutative law. In the 8th class, you must have studied the commutative law, associative law, distributive law. So commutative law means like if we talk about the addition, 2 plus 3 is equal to 3 plus 2. We can write 2 plus 3 as 3 plus 2. This was the commutative law. Similarly, you have studied the associative law for addition. Like if there are 3 numbers, 2 plus 3 plus 4. So either we can add 2 and 3 first, and then we can add 4, or we can add 3 and 4 first. Like if we do it like this, if you are adding 2 and 3 first and then adding 4, or if you are adding 3 and 4 first and then adding 2, both are the same thing. This was the associative. And distributive law you have studied, like 2 multiplied by 3 plus 4. So this is the distribution of multiplication over addition. We can write it like this: 2 into 3 plus 2 into 4. So these were the commutative, associative and distributive law you have studied in the previous classes based on the number. The same laws we are going to use in the form of set. So commutative law, it says it is work for both union and intersection. A union B is equal to B union A. This is known as the commutative law. And the second one is A intersection B is same as B intersection A. Now, how we are going to prove this one? So whenever in these types of question, whenever we have to prove that the left hand side is equal to the right hand side, we will take the help of the subset. While doing the subset, you must remember that if I say X A is a subset of B, if I say, and B is a subset of A, then only we can say both are equal. If A is a subset of B and B is also the subset of A, if both the things are satisfying, then only we can say that A and B are equal. This is the whole concept which we are going to use in proving every law. To prove the left hand side is equal to the right hand side, we will say that the left hand side is a subset of right hand side and right hand side is also the subset of left hand side. Then only we can say that both of them are equal. And when we can say that A is a subset of B, we will take one element. This is the procedure we have studied in the last to last class. How we can prove that A is a subset of B? We will take one element, let's say X belongs to A, and we will prove that this element does also belongs to B. If X is the element belongs to A and X is also the element belongs to B, then we can say then A is a subset of B. Similarly, in the second case, we will take one element which belongs to B and we will show that X also belongs to A. Therefore, we can say B is a subset of A also. So from these two, we will say both of them are equal. This is the algorithm which we are going to follow. Are you getting it? The algorithm, which algorithm we are going to follow over here? We will show A is a subset of B and B is a subset of A also, then only we can say both of them are equal. This is the whole algorithm which we are going to use in proving every equality. Getting it, Shillong and Kohima? Okay, so let's start the proving. So first we have to prove the left hand side. I am doing the first one, you can try the second one same itself. So first we can say let X is an arbitrary element of A union B. So if X is an arbitrary element of A union B, we can say X belongs to A union B. If X belongs to A union B, it implies that X belongs to A or X belongs to B. It implies, we can also write, we can interchange this one, X belongs to A or X belongs to B. We can write this one as X belongs to B, it implies X belongs to B or X belongs to A, which implies X belongs to B union A. Right, what we have done, first we have taken X belongs to A union B, then according to the rule, we can say X belongs to A or X belongs to B, and then we can swap both of them. So X belongs to A or X belongs to B, or we can say X belongs to B or X belongs to A, both of them are the same thing, this is the way. And then we can say from this one, X belongs to B or X belongs to A, we can write X belongs to B union A. So we have started from here and we are going up to here. You can see we have started from A union B and then we have reached to B union A. So therefore we can say A union B is a subset of B union A. This is the first equation you can take. Right. Now we will say let X belongs to B union A. Now we will take the element X from the right hand side and we will prove the right hand side is also a subset of left hand side. So we'll say, let's say X belongs to B union A, so we can write X belongs to B or X belongs to A. 2 plus 3, we can write this one as 3 plus 2 also. So we can also write this one as X belongs to A or X belongs to B. And from this one we can combine both of them as X belongs to A union B. So now you can see we were started from here and we are ending up here. X was the element of B union A and X was also element of A union B. It means B union A is the subset of A union B. This is the second point. Now from both of them, from first and second, if this is the element of a subset of B and that was the element of subset of this, so we can say A union B is equal to B union A. This is the way in which we can prove both of them are equal. Getting it? You can swap X belongs to A or X belongs to B. Shillong, are you getting it? Okay. Now let's do one more example. The second part you can do yourself in the same way. Let's do one more example. This was the commutative law. Let us do the associative law. So associative law, let's say there are 3 sets, A, B and C, there are 3 sets. So we can, it means, it says A union B union C is same as A union B union C, and same goes work for the intersection. A intersection B intersection C is same as A intersection B intersection C. So we are going to prove the first one, second one you can prove. So we have to prove the first one. So we will prove the left hand side is a subset of right hand side and right hand side is a subset of left hand side. So how we can prove? Let X belongs to A union B union C. first we will assume that X is the element of this thing. We will prove that X is also element of the right hand side. Then only we can say these are two are the subset. So we can say it implies X belongs to A union B or X belongs to C. We can also write X belongs to A union B, we can open. If X belongs to A union B, we can say X belongs to A or X belongs to B or X belongs to C, same. We can write it like this now, X belongs to A or keeping this in bracket, X belongs to B or X belongs to C. Now we can say this X belongs to B or X belongs to C, since we have taken that in the complete bracket, so we can write this one as X belongs to B union C, and now from these we can say X belongs to A union B union C. So from this we can say since X was the element of that thing and X is the element of this thing also, so we can say therefore X A union B union C is a subset of A union B union C. Getting it? In the same way, we can do it for the right hand side. We will prove the right hand side is a subset of left hand side also. So we'll say let X belongs to A union B union C. Same procedure we have to do over here. It implies that X belongs to A or X belongs to B union C. It implies X belongs to A or X belongs to B or X belongs to C. Again, we can take A and B into one bracket or X belongs to C. Now this thing X belongs to A or X belongs to B, we can write this one as X belongs to A union B or X belongs to C. The reverse process we can also do, and here we can write X belongs to A union B union C. Therefore, we can say since X was the element of this thing and X is the element of this thing, so A union B union C is a subset of A union B union C. This is the first equation, this is the second equation, right? Now both are the subset of each other, so from the first and the second we can say A union B union C is equal to A union B union C. This is the answer. And this is the same algorithm we are following. We are proving both of them are subset of each other, and then we are saying that both of them are equal. Getting it? Any doubt till now? So this was the associative law. So let us do one distributive law also. So it will be more clear to you how this working, the process of proving works. So distributive law works for both the union and for the intersection. So distributive law is same, means like we write if it is written 2 into 3 plus 5. When it is written 2 into 3 plus 5, we write this one as 2 into 3 plus 2 into 5. Or we can say this one as distribution of multiplication over addition. But in the between the same multiplication addition sign is there, which is there between the bracket, in the bracket. So similarly, if it is A union B intersection C, so here it means the distribution of union over intersection, the distribution of this union over this intersection. This is the meaning of this thing. So this has to be equal to A union B intersection A union C, like this. So I hope you are able to relate it. And similarly, it can be like distribution of intersection over union. A intersection B union C, it means A intersection B union A intersection C. This is the meaning of distributive law. You can relate it with this multiplication concept, 2 into 3 plus 5, that can be written as 2 into 3 plus 2 into 5. Same thing we are writing, A union B intersection C, this can be written as A union B intersection A union C. So now let us prove this thing. So first one we are proving. So first we will say that let X is an arbitrary element and X belongs to A union B intersection C. So we can write this mean as, this implies that X belongs to A or X belongs to B intersection C. This can be written as X belongs to A or X belongs to B. This is intersection. So and X belongs to C. Right? Now we can distribute this OR over AND. So we can write this thing as X belongs to A or X belongs to B and X belongs to A or X belongs to C, distribution of OR over AND, like this. So X belongs to A or X belongs to B, we can write this one as X belongs to A union B and X belongs to A union C. And now both of them can be rewritten as X belongs to A union B intersection A union C. So here we have started from that one and we have started from here and we have reached up to here. Therefore we can say A union B intersection C is a subset of A union B intersection A union C. This is the first equation. In the same way, we can take element X belongs to A union B intersection A union C. It implies that X belongs to A union B, and since there was intersection, X belongs to A union C. Now we can write it as X belongs to A or X belongs to B and X belongs to A or X belongs to C, we can write. Now since we have to do the reverse process, this is the reverse of the distribution. We have to take this X belongs to A as common. So we can write this thing as X belongs to A or X belongs to B and X belongs to C. We have taken the reverse process, like taking 2 as common from both of them, so it will be 3 plus 5. So now it is X belongs to A or X belongs to B intersection C. Now it means X belongs to A union B intersection C. Therefore you can write A union B intersection A union C is a subset of A union B intersection C. So now from first and second, we can say that both of them are equal. Therefore, A union B intersection C is A union B intersection A union C. This is the way in which we can prove. Getting it, all of you? Shillong, getting it? Okay. Now we have done so many questions. Now you get a pretty much idea like how we can prove. So now next one, try on your own. So if this is called De Morgan law. And it means that A union B of complement of A union B, that is A complement intersection B complement, and second one says A intersection B complement is equal to A complement union B complement. This is just like when we have taking the complement of union, that union will be converted to intersection like that. So try to prove with the same way as we have done the previous one. Try to prove it, and if you done it, just let me know, and if you are not getting it, also let me know, then we will prove. Just first try on your own. And Kohima, are you able to solve? Okay, Shillong, I will solve. Okay, still in process. Okay. Okay, done. Okay, that's great, Kohima. Okay, so now let's do this one. So first one I'm proving. So, and the useful laws which we have written over there, here, we will take the help of the last one and these one. We have to take the help of these laws while proving those. So you can see, so let us do the first one. So first let us say that x is an element of the left hand side, A union B dash. So if you remember that x belongs to A, complement of A, it means x does not belong to A. So it implies x does not belong to A union B. And if x does not belong to A union B, I have told you when it is does not belong, then the union will change to that intersection. So we'll say x does not belong to A and x does not belong to B. Now since x does not belong to A, it means we can say x belongs to A dash and x belongs to B dash. Now there is a and is written in between, so x belongs to A dash intersection B dash. Therefore we can say A union B complement is a subset of A dash intersection B dash. Second thing, let x belongs to A dash intersection B dash. So first we will say x belongs to A dash and x belongs to B dash. So therefore we will write x does not belong to A, and here we will write x does not belong to A and or we can write it like this in the same way, like you can compare it with this one, this step. So x does not belong to A and x does not belong to B. Now if x does not belong to A and x does not belong to B also, we will say X does not belong to A union B, just the reverse process. And X does not belong to A union B, it means X belongs to A union B complement. Therefore, A dash intersection B dash is a subset of A union B complement. So from these we can say A union B dash is equal to A dash intersection B dash. Getting it, Shillong? Okay. Now there are so many different types of the proving part, but in all of them the basic concept would be like this. You have to prove the left hand side is a subset of right hand side and right hand side is a subset of left hand side, and then only you can show that both of them are equal. This is the algorithm we will use. So now try some more questions from your book, and then you will get a good command on how we can prove these things. So one exam question on this one. Let's say if A belongs to a natural number such that An is equal to set of all Ax such that X belongs to N. So describe the set 3n intersection 7n. A is a natural number, A belongs to natural number such that An is equal to Ax, set of all Ax such that X belongs to natural number. So how would you describe the set 3n intersection 7n? So basically here we have to use the logic how we can solve. This An is set of all Ax and X is a natural number. It means this Ax is a multiple of A. So 3n would be, if we write 3n would be set of 3x such that X belongs to natural number. Now if X is a natural number, so 1, 2, 3, 4, 5, it will be a multiple of 3. So it will be 3, 6, 9, 12, 15 and so on. Similarly 7n. Now 7n means like this we can write 7x. So x is a natural number, so it means 7 times 1, 7 times 2, 3, 4, 5. So 7, 14, 21, 28, 35 and so on. Now since we are taking the intersection of both of them, intersection of both of them means we have to figure out what is the common terms in both of them. So common terms in both of them you can see here it will be 21 also. So first element is 21 and the second element which is common to both of them would be in the table of 3 42 will appear and in the table of 7 42 will be appear. So basically the LCM of 7 and 3 is 21. So 21 is common, then 42 is common. So we can write 3n intersection 7n. These are the terms 21, 42, 63, 84 and so on, which are the multiples of 21. So multiples of 21 will be like, we can say these are nothing but 7x, where x belongs to natural number, and the 7x can, 21 we can write 21x, and we can write this one as 21n. So the set is 21n. I hope you got it. Getting it, Shillong and Kohima? Okay. So now this was all for today, In the next class, we will do the question word problems on the Venn diagrams. Today we have discussed the operations on the Venn diagrams and some proving type theorems. And the next class we are going to do the operations on the Venn diagram, in which we will solve the problems related to daily life. That's all for today. Thank you.